Okay, so I'm cheating on this video because I dug back through. If you look at the top, it says arithmetic with 18. So I will admit that I am a hoarder, just probably a little bit more than a pack rat, and I like to save things just in case I need them later. So what I'm going to do is cheat and use these slides that I made 2 years ago and just talk over the top of them, and we'll see if that works all right for this topic today. When we're doing arithmetic with radicals, we have to think back to an earlier chapter when we're looking at things like this right here. If I have 2x and I'm asked to add it to 5x, am I allowed to do that? Well, sure, and when I add them together, I get 7x. Or if I take 3y squared and minus 9y squared, we put them together and combine the coefficients and get negative 6y squared out of that. But then if we are asked to add something like 4x plus 3y together, are we allowed to add those together and combine them into a single term? Most of you would say, well, of course not. We can't do that because those guys are not... Oh, look, I have an infinite cloner on there. We want him gone. Because those are not like terms. So in algebra class, anytime we're adding, anytime we're subtracting, we can only combine terms together if those terms are like terms. So then if we're looking at things like x squared plus 7x, sometimes students say, well, those are alike. But if we look at them, their exponents are different. X squared is not like plain old x to the first. And so therefore we would stop and say, well, those aren't like terms either. I can't combine them together. The things that are underlined in blue, those would be our complete and final answers, the most concise way we can write that. So bringing that back to radicals that we've been working with in this chapter, I say if I want to add the square root of 2 and the square root of 6 together, even though, yes, they both have square roots in them, just like, yes, up above, those both had x's in them, they were different. Those terms are not alike. So again, the blue underline indicates that's as simplified as I can get. Those guys are not like terms. We can't combine them together in any nicer way. Okay. So when we're adding radicals, when we're subtracting radicals, if the radical piece is exactly like the other one, then we can combine those terms together, just like we did with x's and y's back in probably chapter 1 of any textbook. So if I have 1 square root of 3 and I want to add 6 square root of 3 to it, I can do that, and altogether I have 7 square roots of 3. When we keep sliding down the page, if we look at 4 square root of 3 and someone asks us to add that to the square root of 12, okay, initially those are not like terms. I can't combine them together as they're written. But remember that square root of 12 can be simplified. 12 can be broken down as 2 squared and 3, which means a 2 can come out from under the radical and the 3 is stuck inside. And so therefore, 4 square roots of 3 plus 2 more square roots of 3, those can be combined together, and we can end up with 6 square roots of 3 in the end. If we're given 2 radical expressions and asked to add them together or subtract them from each other, we can only combine them together into a single term or a more concise term if the pieces under the radical are the same. Okay. Just because they're not initially when we copy them from the book doesn't mean that we can't do any more with them. If one or both radical expressions simplify, we need to simplify them first, and then if they're alike, okay, after that, we can combine them, and if they're not, then we don't. Okay. So, for example, and I do have some scribbles underneath here to kind of, I guess, point you in the right direction. But at your desk, if you want to pause the video for a minute and play with those 2 guys there, you can simplify the square root of 20 and the square root of 45, and maybe I will put this back now that you've already seen it. Okay, that says 27p squared by the 9 there on the front. And you can break each of those radicals down. From there, try to combine your like terms. if there are any, and you stop if there aren't, and see what you get in the end. So hopefully you pause the video to work on those things, and if we simplify the square root of 20, notice a 2 gets to come out from under the radical. This 2 gets to come out right here, and the 5 is stuck underneath because there's not enough of those 5s. Similarly, with the 45, there are 2 3s, so the 3 can come out. And again, there's only one factor of 5, so he is stuck under the radical there. The arithmetic, the 6 and the 2 that were out in front of those initial radicals, they get hooked on. Since they were products before, they're products still. So I have 12 square roots of 5 plus 6 more. And since those terms are alike, we can put them together to get 18. With the 27 p squared, the 108 p squared, the 48 p squared, if we break down 27, there are 3 factors of 3 there. So remember, if there's more than I need, I only need 2 for a square root, then I make groups the size I need and write down how many extras are there after that. So I can make a group of 2 and a group of 1. That means the 3, I think I came here next. Nope. Slide out of the way. The 3 and the p get to come out from under the radical, and this 3 that's all alone is stuck underneath. Okay. Over here on the 108, we get both a 2 and a 3 that get to come out. Putting them together is a 6. And the p squared comes out as a p, and this lonely old 3 stays right where he is. From the 48, 2 2s come out, the p comes out, and again, that 3 is stuck underneath. Putting like terms, finding those products now, we can multiply 9 times 3 and 14 times 6 and 2 times 4 and keep the p's where they are and clean things up to be here. And then when we combine our like terms, 27 minus 84 plus 8 leaves us with a negative 49, and the p and the square root of 3. Okay, there in the blue circle, we went in a big circle there. So if you have questions about adding and subtracting radicals, get with me on that. Call into my office hours once I get them set up, whatever you need. Next video, we'll be multiplying and dividing.